Hi, good morning everyone. Today, today, we, today I'm going to talk about this quick sort. Uh, there are many sorting techniques. So sorting in the sense actually arranging the list of elements, arranging the list of elements into one order. This order is maybe ascending order or it may be descending order. Okay, right. Now I'm going to explain about how to arrange the elements in ascending order. So this is what this idea of sorting, and this is implemented by many sorting algorithms. One among it is quicksort. There are many sorting algorithms. One among it is quicksort. Right. Now I'm going to talk about quicksort. The idea of quicksort is divide and conquer. We'll divide the whole list of elements, and this division will be based upon pivot element. This division will be based upon pivot element. Now look at this. The pivot element, assume this is my pivot element. Now left of my pivot element, left side of the pivot element is always lesser elements. Right side of pivot element always will be greater than this pivot element. So based upon this pivot element, we'll divide the whole list into two partitions. Based upon this pivot element, we'll divide the list of elements into two partitions. Now this partition is 1 and this partition is 2. So quicksort is also called as partition exchange sorting. Partition exchange sorting, because we will be dividing this partitions based upon this pivot element, and exchange process will be going to see in couple of minutes. Right. Now what is quicksort? Quicksort is sorting is arranging the list of elements into one order. Quicksort means we'll follow one fundamental idea, which is divide and conquer. We'll divide the whole list of elements based upon pivot element into partitions. Right? The first partition of pivot element always will be less than of pivot element. The second partition, that is right side partition, always will be greater than the pivot element. Okay, right. And let's see about the two things. The one is how partition will works, or what are the steps which will be taken place into partition, or how to implement partition and how to implement quicksort. That is the algorithm part. The implementation part also we'll discuss in this video. Right? Right. Now let's see some example. Now I'm taking some example. My example is 21, 7, 6, 5, 10, 11, and 28, 45, 38, 21. Okay, this is my list of elements. Now I am putting all these elements into one array. Okay, right. So as I am telling, this will be an array. I am giving the index for this array. Now I am putting all the elements into array. Okay, right. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what is this numbering? These are indexes. We already know about this. Indexes. Indexes of the elements. Right. Now, I told you that pivot element is the root point or the key role of your quicksort. Now, I can consider pivot element as, the first element can be pivot element, or the last element can be pivot element, or any element in the list can be considered as pivot element. ఇక్కడ ఉన్న లిస్టులో మనం ఏ ఎలిమెంట్నైనా పివోట్ ఎలిమెంట్గా తీసుకోవచ్చు. ఓకే, లిస్ట్లో ఫస్ట్ ఎలిమెంట్, లాస్ట్ ఎలిమెంట్, మిడిల్ ఎలిమెంట్ ఆర్ ఎనీ ఎలిమెంట్. Any element can be considered as pivot element. Right. Now I am taking pivot element as the first element. I am taking first element as the pivot element. Okay. Right. Now this is my pivot element. In which place my pivot element is? In first place, or in the index of 1 my pivot element is there. Now this is I index, or this is the lower bound, and this is my upper bound. Okay, and I am taking this as the starting position of my array, and this is what my ending position of an array. Right, I have taken one list of elements. Now and I have given all the indexes to the list of elements. The first element is lower bound element, the last element is upper bound element, and this is my starting point and this is my ending point. Right. Now what is the idea of quicksort? The idea of quicksort is we will be finding the lesser elements to this pivot, and we will be finding the greater elements to the pivot element, because our idea is to divide the list into two partitions. So pivot element, lesser element should be at left side, pivot element, greater element should be at right side. If we find any element is less than the pivot element, we'll keep this side as it is left side. Look at this array. This is your left side, left partition, and this is your right partition. So right side always should be greater than your pivot element. Left side always should be lesser than the pivot element. So to get this exactly correct appropriate list of elements, we will be comparing pivot element with the next element. So to compare this, we will be going for one algorithm. The algorithm is, we'll follow the algorithm. That the algorithm is, when you found one element, when you compare this element with the next element, when you found the relation is lesser, when you found the element is lesser, so lesser element can be at left side, right? So what we'll do is we'll increase the index. And if the next element is also lesser element, we'll increase the index. Which index? This starting index. The starting value will be increased until you found greater element. Why greater element? All the greater elements has to be arranged in right side, right? And the same thing is applied in backward. If you found any greater element than your pivot element, so that can be here. When your end pointer will decrease, when the element is lesser, that the element has to be come to left hand side. ఓకే, సో ఇదొక లిస్ట్. ఈ లిస్ట్లో ఇది నా పివోట్ ఎలిమెంట్. నా పివోట్ ఎలిమెంట్ కంటే గ్రేటెస్ట్ ఎలిమెంట్ అంటే పివోట్ ఎలిమెంట్ కంటే లార్జెస్ట్ ఎలిమెంట్స్ మనకి ఇక్కడ ఉంటే వాటిని మనం రైట్ సైడ్లో వేస్తాం. ఈ రైట్ సైడ్ పార్టీషియన్లో ఏ ఎలిమెంట్ అయినా తక్కువ ఉంటే దాన్ని మనం ఇక్కడికి తెస్తాం. ఓకే, స్వాప్ చేస్తాం. ఓకే, రైట్. నౌ లెట్స్ see how it will be works. Now we are at this place. Now 21. So what we'll do is we'll check this 21 with the 21. So it is found to be lesser and equal to, my pivot element is 21. So the first index is 21. Now lesser equal to, what we have to do? Increase the index. That means your starting pointer is moving from 1 to 2. Now we are at this place. Now again check. Pivot element is 21. Next element is 7. 21 and 7 found to be lesser. Lesser element అంటే లెఫ్ట్ సైడ్లోనే ఉండాలి. సో మళ్ళీ ఏం చేస్తాం? మళ్ళీ ఇండెక్స్ని ఇంక్రీజ్ చేస్తాం. అంటే ఇప్పుడు ఇక్కడికి వస్తుంది. స్టార్ట్ పాయింటర్ విల్ కమ్ హియర్. ఓకే, నౌ 21 and 6 lesser. Yes, increase the index. Now will come here. 21 5. Now it is also lesser, found to be lesser than your pivot element. Then again increase the index. Now will come here. 21 10. Relation lesser means you have to increase the index. Now will come here. 21 9 11 lesser. Then will increase the index. Now will come here. Now here is my start pointer, or here is my start. Now index will come here. Now 21 comparison will be with 28. Now found to be greater. When it is found to be greater than your pivot element, you have to stop the process of increasing the index. That moving to the next, that you have to stop. So here you have to stop here. Now here you have to stop. Then you should start the process from backward. From here you have to start. Right. Now back value is what? That means ending upper bound value is 21. Now what is your pivot element? 21. 21 lesser equals to 21 or greater 21? It is equal to. So it is not lesser. When it is lesser, then only when it is greater you have to move a bit. Right? Now it is what? It is equal to. When it is equal to, what you have to do? Now you have to swap. Which number you have to swap? 21 will come here and 28 will go here. So after the first swap, the elements are 21 7 6 5 10 11. After 11 21 45 38 28. Now these two elements will be swapped. Now indexes 1 2 3 4 5 6 7 8 9 10. Now where is your start pointer? Here is your seventh index is your start pointer, and end pointer is where? Here at 10th pointer, 10th place. Okay, right. Now again we have to compare with this pivot element. Now pivot element is 21 with the 21 lesser equals to 21. When it is lesser equal to, you have to increase the index. Now we'll come here. Now 21 versus 45. It is greater. When it is greater, you have to stop the process of increasing the index here. Now your start pointer is here now. Now come to here. Now again, where is your end pointer? Here is your end pointer. Now 21 versus 28, it is greater. When it is greater, greater element should be in right hand side. Now leave that. Now decrease your end pointer. Now it comes to here. Okay. Now 38, 21 comparison with 38 found to be greater. When it is greater, when it is greater, you have to leave this here. You have to decrease the end value. So here you will come. Now end will be come here. Now 21 versus 45. This is also greater. So greatest element should be at right hand side. We'll leave here. Now we'll decrease the index. So we'll come here. Now 21 and again this 21. So it is not greater element. It is equals to element. It is equals to element, right? So when it is equal to, what we have to do? So end pointer will come here, right? Decrement end pointer here. Now your start pointer is here. When your end pointer will come here, that means when the starting index is crossed the ending pointer. End is decreased from last place to this place, right? Now start is increased from this place to this place. So one moment start pointer will cross your end pointer. So what we'll do is we'll stop our process here and we'll find the place of pivot element. We'll find the place of pivot element as this. Fine, right? So end pointer is here, right? Now the sorting is, the elements are 21, 7, 6, 5, 11, 21, 45, 38, 28. Now this is my list. Now this is my pivot element place. This is my pivot element place. Now you can see this, that all the elements lesser or equals to pivot or left hand side, all the elements greater to this pivot are at right hand side. And it is true that it is not sorted, but we found the correct place or appropriate place of this pivot. So pivot place is where? This is 6th index, 6th place. 21, 7, 6, 5. Acha, I missed some element, right? I'm sorry. So here is one more element. Look at the above. 10. 10 is one more element. Right. So that's what index has got changed. 7, 8, 9, 10. These are indexes. Okay. Now, so left hand side partition. This is my partition 1. Look at partition 1. All the elements are lesser equals to pivot element. And all the elements are greater P2. P2 partition is greater than pivot. P1 partition is less than pivot. Okay. Right. Now let's see the algorithm on base of what we were completed this task. And we'll trace even the algorithm. The algorithm is now I am writing the partition algorithm. Partition array lower bound upper bound. Now my pivot element is at lower bound. A is my array. Now stat is equal to lower bound. Stat is equal to lower bound. Now end is equal to upper bound. Fine. And What is this? I'm doing partition, array of elements. Now lower bound, upper bound. Now my pivot element is my first element, which is at lower bound. Now my start is lower bound, end is upper bound. Now my algorithm will works like this. While a of stat lesser is equal to pivot element, then we'll increase the starting point, and while a of end greater than pivot element, then we'll decrease the end. Okay, now look at this. Now this is my partition algorithm. So I have list of elements. Now what I did, A is my array. Now this is my array. Lower bound is 1, upper bound is 10. Now pivot element is equal to lower bound. Now which is 21, my pivot element, first place. Start is lower bound. Now from here I am starting, that is 1 index. Upper bound is 10 index. Now what I am doing, while a of stat. What is a of stat? 21. A of stat is 21. Less than or equal to pivot, that is 21. Pivot also 21, right? Now a of stat is 21, pivot is 21. When it is lesser equals to, now you have to increase the index, right? Now you have to increase the index, hence we'll go to this 7. Now until this condition fails, you have to repeat it, right? Now 21 will be the pivot element. Now a of stat is what? 7 this time. Now 7 is lesser equals to 21. 7 is less. Now look at this, 7. My next starting index increased. Now next element is 7. 7 lesser equals to 21. Condition true. Now we'll increase the index size. Now the next element is start plus plus. Will come here. Next element is 6. Now this time 6. 6 lesser equals to 21. Again 6 is less than from 21. Now again increase the start. Now again we'll go to here 5. Now this time is 5. Now not it is 6, it is 5. Now 5 lesser equals to 21. Condition true, 5 is less than. Now increase the start. Now we'll go to this place. We'll go to this index. Now what is the index value? 10. Now 10 lesser equals to 21. Condition true. We'll come inside of the loop. Start plus plus. Index will be increased and we'll go here. This index is having the element of 11. Now we'll compare 11 versus 21. Found to be lesser. Again index will be increased. Now we'll come to here 28. We'll come to this place 28. Now 28. Now 28 lesser equal to pivot. Right? 28 lesser equal to pivot, greater. When it is greater, it will not go inside of your loop. So instead we'll come here. What is here? While a of end greater pivot element. What is a of end? 21. A of end is 21. So now we'll come to a of end. A of end element is 21. 21 greater pivot element. 21 greater pivot. Pivot is what? 21. So 21 is not greater pivot, right? So we won't go to inside. Will not go to inside. So then what we will do? We will be checking the condition. We will be checking the condition if stat less than end, then swap. What will swap? A of stat comma a of end. We'll swap a of stat and a of end. Right. Now when this condition fails, we'll come to this. Now what is stat value? Look at what is stat. Now here it is pointing 7. Stat value is 7. Now start value is 7. What is end value? 10. Now 7 is less than from 10. So we will be perform swap operation. So in this swapping, where we'll go? 21 will come to stat and 28 will go to here. A of stat and A of end will be swapped, exchanged, right? Now 21 will come here, 28 will go here. Now look at this. So 7th place should be occupied with 21 and 10th place should be occupied with 28. Now look at the next step what we were considered. Now 7th place is 21, 10th place is 28. Right? Now again what we'll do? Now we'll repeat the same condition until it fails, right? Now where we'll go now? Where is your stat pointer? Here is your stat pointer. Now your pivot element is 21. Now again what we'll do? Now here is your stat pointer 21 and it is your end pointer. So again what we will do? We will be doing the same conditions. Now this time is what? Where we are in 7th pointer. Now 21 and 7th pointer also 21. Again step repeats, right? A of stat is what? This 21. Now A of stat is 21, pivot also 21. Lesser equals to pivot. It is equal to. When it is equal to, you will increase the stat index. Now stat index will be increased and will go here. Right? And this time what is there? 45. Now it is 45. 45 lesser equal to pivot. No condition fails. We won't go to increase the stat. We'll come outside. Now A of end is what? A of end is what? 28. Now A of end is 28. Pivot is 21. Now 20 is greater than pivot. So end minus will decrease end value. That is pointer, end pointer will come here. End pointer will come here. Now again loop repeats until this condition fails, right? Now what is the 38? This time is 38. 38 greater than 21. Condition true. Again end minus. Now we'll come to here. Now end pointer is here. End pointer is here, which is 45. Again we'll be repeating the loop. 45 greater than 21. Condition true. Again we'll be decreasing. Where we'll go this time? We'll come here. Okay. Now end pointer is here. So now same. Now 45. Now end pointer is what? This time it is moved and it came to 21. 21 greater 21. Condition fail. Now we'll come outside. Now we'll see the stat and end bits. Right? What is the stat? Here? 7. Right? Now what is end 1? End 1 is what? What is stat and what is end? 7 and 7. So when it is 7 and 7, condition fails. Now swap will not be done. Then what will be done? What will be done is, we will be swap A of lower bound comma A of end. When this condition fails, what will swap? A of lower bound comma A of end. That's what we were swapped this value with this pivot element. So surprisingly both are same. I mean that here it is 21, here it is 21. That's why you may not be recognizing how the operation goes, but the process of doing this algorithm is this, that you have to follow this. So now 21 will be replaced with your lower bound value, which is 21. Right, now look at your algorithm. Now this first index 21 is this index, this 21. Now this index 21 is this 21 pivot element as per the algorithm. Now look at this. Now this is your partition 1 and this is your partition 2 and this is your pivot element. Okay. Now we'll return here value, which is return end value. What is return? What is end value? 7. What is end value? 7. Now 7 is what? Integer value. Why you have to return this value? Because it is the value of your pivot element. It is the value of your pivot element. So you have to return this. So this condition has to be repeated. This condition has to be repeated. I mean, we have to write a counter loop, right? From where we have to stop. That we have to write, no? So that counter loop is this. Here you have to write a counter loop, which is your counter loop while stat less than end. That's it. While stat less than end. So until this condition true, will be going inside. So look at this. End is 7, stat is 7. So 7 less than 7. Condition fail. That's what we will be stopping the process of going forward and coming backward. This is our counter loop, or this is my condition to stop this process. Okay. Now let's see how partition, how quicksort will works. I am writing the algorithm for quicksort. Quicksort algorithm is quicksort is applied for an array of elements, lower bound and upper bound. Now, if lower bound should be less than upper bound, that is when you have lower bound and upper bound elements, and when it is lesser only you can sort the elements, right? Now lower bound is lesser from upper bound. Now we will be doing partition array of elements, lower bound comma upper bound. Now partition will write a return value, right? I mean, it will return a value. Look at this. It will return a value, end value. Now I am putting the variable which is location. Now partition will return an integer value which is location. Okay. Now quicksort, that partition is a comma lower bound comma location minus 1. Now this is, now I told you in the beginning of the video that pivot element before one partition, pivot element after the other partition. So location is my pivot value. So lower bound to location minus 1 will be applied again quicksort. Now the other partition is quicksort array location plus 1 comma upper bound. This is quicksort algorithm, and this is how partition will work. Now when you come here, this is the list of elements, no? Now when you come here, again this partition should go under this. Now again you have to do the partition by considering the first element as pivot element. Again you have to do the same. Now this is your pivot, this is your pivot element again. Now all these elements have to be go through with this implementation logic, and you will be getting one list here, right? One list here. Now here also you will be sorting by following the same process. You will be sorting this list. So you divided two partitions. Once after you complete this partition sorting, again you can again the whole list will be completes. Now when you individually sort this and sort this, finally you will be getting the whole list So partition will be applied here, and here you will be getting the list. So my next video we will be calculating the complexity of your quicksort. So quicksort worst complexity is big O of n square. It is the worst complexity, and the best and average complexity is big O of n log n. The best and average complexity of quicksort big O of n log n. So it is compared to the best complexity. If you compare with your selection sort, insertion sort, then it is the best complexity. So most of the people will use quicksort for sorting. So this is the ideology of complete quicksort. Thank you all.